Hello, today we will make a Mechatronics system design project proposal presentation to you. The name of our project is Light Source Target Mechanism. We are carrying out this project together with our project advisor, Cüneyt Yılmaz. Our project team consists of me, Ayşe Simay Yalçın, and my teammate, Bengüsü Aydın. The problem we addressed when starting this project was security. Crimes that take place all over the world at any time endanger everyone's safety. Theft, human smuggling, and refugee problems are common problems of every country in the world. When we look at the graphs, 17% of the criminals who went to jail in Turkey in 2018 are criminals who committed theft. In the graph on the right, we see the reflection of the refugee problem, which continues to affect the whole world in Turkey. For this reason, border protection systems are vital for every country in the world. We wanted to produce an alternative solution to these problems by bringing an innovative perspective within the scope of a mechatronics project. In our project, we aim to target light source in dark environments with light sensors. In this way, we will design a system that aims to minimize security flaws that may occur in dark environments and times. When we did a literature search on this subject, we saw that there are many different products in the field of surveillance systems. CCTV cameras are the most common among them. CCTVs cannot target any danger and they are only capable of recording images. With the increasingly widespread smart home systems, IoT-based intrusion detection systems have emerged. In these systems, all electronic devices communicate with each other via the Internet. Therefore, it is a system open to malware. Fiber intrusion detection systems, on the other hand, use a fiber optic sensor which uses optical fiber to transmit signals from a remote sensor to electronics that processes the signals. The projects on this slide are projects designed by Aselsan for border protection. The alarms and video footage from the areas surveyed in the Asurland project are instantly displayed at all command control levels. SEDA system is designed to detect supersonic projectiles and to calculate shooters' location. As a result of these researches, it has been determined that there is a lack of a system that can target light source with only light sensors. For this reason, we wanted to design an affordable, useful, and reliable project in addition to existing solutions for people who want to provide protection in dark areas. This project can be used in factories, country borders, offices, and homes. Identifying potential stakeholders before designing the project is an important step. While doing this, we try to identify the parties that have an interest in this project and that can affect or be affected by it. We categorized our stakeholders into internal and external. You can see our stakeholders on this slide. After identifying our stakeholders, we determined their expectations. Each stakeholder has a different expectation. For example, the provision of scientific benefits is expected by TÜBİTAK and the university. Good risk management and use of contact is important for the user. Then, by researching the market requirements, we created the design parameters necessary for this design to stand out and be desirable in the market. The assumptions and limitations are then defined. Identifying them is crucial to understanding the circumstances in which our project will succeed. In our project, we assume that the backside of the system is safe, and the 180-degree area in front of it should be observed. At the same time, we assumed that the distance of the target was within the range of the field of view, and the light sensor sensitivities are the same. Finally, the project should follow the timetable.
From now, I will continue with the design suggestions. To understand the logic basis of the system, we will examine the conceptual design after the problem definition. The robotic arm is placed in a dark area to be controlled. After calculating the number and geometry of the light sensors, the sensor carrying plane is placed on the robotic arm so that it sees the light source. Each light sensor on the robotic arm generates a volt when there is a light source in the environment. There is an arm that directs to the light source by comparing these volt values. At the tip of the arm, there is a camera to monitor the direction of the target. With this camera, images can be taken from the area thought to be the light source. The camera only will be used for tracking to see the target. Image processing techniques will not be used in the project. We designed the system block diagram to represent the workflow and processes. First, our sensors, which detect a light source in the dark area, send information to the controller. The controller detects the location of the light source with the information from these sensors. Then, it sends a control signal to the motors so that the system can orient itself to this location where the target is. The motor encoder creates a closed control system by sending the position information of the motor to the controller. When the motor turns the desired direction, the area from which the light comes can be monitored with the camera at the end of the arm, so that the people responsible for the security can only watch the light area in case of any danger. After completing literature research and establishing stakeholder expectations, we determined the technical requirements. According to these technical requirements, we decided on the design specifications. We wanted our system to be easily controllable, sensitive, portable, to work with a certain accuracy, and to be resistant to temperature difference in the environment. On this slide, you can see which programs we will use to design and analyze the system that will be created after the requirements development steps are completed. We will use SolidWorks program for mechanical design and analysis, MATLAB for mathematical modeling and control design, Proteus for electronic circuit design. We know good risk analysis generates as much control as possible. We started the risk management process by identifying potential hazards as the first step. The risks are assessed resulting from possible hazards. Later in the project, we may consider making changes to reduce the resulting risks. If one or more of the sensors fail, the location of the target will not be detected correctly by the system. Also, if there is no additional source to power the system during a possible power outage, the system will not be able to operate. These risks are the substantial points that should be taken into consideration at the design stage of the system. After the conceptual design, we specified our project outcomes for the budget estimation. As a result of the project, our outputs were determined as design, technical report, and prototype. The cost estimation process of the project does not end when the project starts. It must be monitored and adjusted as it progresses. In our timetable, we have determined the order of the work packages according to the design and production steps. We set January as the deadline to make the project a production-ready design. Likewise, we marked the end of the prototyping and reporting process of the project as June. We have completed our project proposal presentation. Thank you for your attention.